you are you know how to solve the problem and you have an outline about solving those problems in your mind, then it would be very easy to solve that problem. So you need to give a lot of time about thinking process, like how we can proceed, what are the necessity, what are the requirements to solve those problems. Once you have in your mind what you need, then the problem which you are just start to write and start to solve, it is going to take 30 minutes. But if you make a criteria, make an outline in your mind, then it will take only 10 minutes. Okay, so what I was saying that where G and H are sufficiently smooth function, and keeping in mind the theory of eigenvalue and eigenfunction, which we saw through an examples, we need the compatibility condition that the value of the function G and H should be zero on the boundary of the domain to ensure that the solution will be a C2 function. Now it will not be unreasonable to assume that G and H will also be a C2 function with the property that G and H is going to vanish on the boundary of the domain on delta omega. Now, from the previous results, if you remember the Eisenfunction expansion, so what was happening in the Eisenfunction assumptions, we were writing that if f is a C2 function and h is a C2 function, then f can be expressed as summation n varying from 1 to infinity an phi n x, isn't it? And from here we calculate the value of an from 0 to, sorry, we cannot write here 0 to 2 pi, rather than we have to take the domain omega, because earlier we took the domain 0 comma a cross 0 comma b, so we took a rectangle 0 cross a, it should be b cross b comma 0, I think, no, 0 comma b, that's fine. So 0 comma b, so it was a rectangle, but here we don't have a rectangle, we have a domain omega. So because of that, this an is going to be, if I am writing any line and you are not understanding a line which I am writing here on my iPad, so please do ask, because each line had some meaning and that is coming from the previous example. So you don't need to worry about that, oh, from where it is coming. You just ask and there is an explanation behind that. So integration omega and it becomes f phi n x ds, I think, isn't it? Yeah. So just remove, this was just memorizing the previous thing. So from the previous theory, this that eigenfunction expansion writes I would like to ask you one thing. The way you're writing um, this GX is going to be summation and varying from 1 to infinite an phi n x, where an is this eigenfunction. So what you guys, how you can relate it with the theory of linear algebra? Can anyone just explain? This is very easy. Can you guys relate it with the theory of linear algebra? And also keep in mind that G is coming from C to omega, where U is solution which is belonging to C to omega. So somehow it is related to this U and this G and H. So can you guys relate how? I just tell you that this can be written as the eigenfunction extension and blah blah blah. But there is also a relation I forgot to explain yesterday class. Do you guys able to relate this eigenfunction to Zx? How I am writing this? Okay, if I am saying that you have n-dimensional space and you know the eigenvectors, basically eigenfunction, their eigenvector. So any vector of that n-dimensional space can be accessed as the linear combination of those eigenvectors, isn't it? So any function from this C to omega, which is generated by these eigenfunctions, so any function g comma h, which is coming from C2, can be expressed as the linear combination of these eigenfunctions, isn't it? So this theory is basically from the linear algebra, and that is known as eigenfunction extension. Actually, there are a lot of things. Sometimes I forgot to write some lines. So this is a way of how I'm writing, because z is also a C2 function and u, that this eigenfunction is the solution which is giving you that is a linear combination. So u will be like phi of x and some of y, isn't it? So this u can be written as this, and then phi is eigenfunctions which is generating the space C to omega, where the solution of this differential equation lies. So we can write any function g of x which is coming from this space as a linear combination of these eigenfunctions. So this is the eigenfunction extension. This is known as basically eigenfunction extension. Like if we talk about the eigenvector extension, then we say that the eigenvector extension is basically any vector of n-dimensional space can be expressed as any vector of n-dimensional space can be expressed as the linear combination of the eigenvector of that system, isn't it? So this is the same thing which we are writing. In the same way, if g of h of x is another function that is a C2 function and vanishing on the boundary of the omega, then this h also can be written as the linear combination of these eigenfunctions. But here, what will be the difference between here, this and this? How hx will be different from gx?
I suppose the coefficients.
Exactly. So every time when you are writing a vector, only the coefficients change. So this hx can be written as bn phi of n x, and this holds pointwise. We say with each series converging absolutely and uniformly on omega. This is an
When you're launching a new
example.
product,
I think you can find this example in the book of Lawrence C. Evans, but it has a very small explanation. Even I had to read and then I got the explanation. So it is up to you. If you wanna follow the book, then you may. Now, let us assume this is not in your notes because I didn't want to solve this problem, but since you guys did were not able to solve it, so that's why I'm explaining. Let us assume the solution u xt may be expanded in the Eigen functions with coefficients depending on t. So what is the motivation behind this line? If we are assuming, because if we are taking this partial differential equation utt equals to uxx, so what we assume that we firstly write it like utt minus uxx equals to 0, then we apply the method of separation of variable, and that is going to give us like x. If we assume the method of separation of variable like this, x of t and h of x, then just keep in your mind the way we proceed. So we are going to get x dash t over x of t is equals to h double dash x over h of x, and this is equal to some eigenvalue lambda. Now what we are doing, we are just solving this. We are just solving this and expressing like this is h double dash x minus lambda of h of x is equals to 0. Rather than taking it minus lambda, we directly put here minus so that it will give us a positive eigenvalue. So we are just solving this and calculating its eigenfunctions, that is going to be phi n of x. Now if we are going to write the whole solution of this system, so there will be t variable as well. Although this is not containing the t variable because this is giving the eigenfunctions of only this equation. So uxt may be expanded in the eigenfunction with the coefficient depending on t. So because of this method of separation of variable, that u equals to xt and h of x. So this we are able to write with the help of eigenfunction. Still x of t is left. So the coefficients of the solution is going to be a function of t. The coefficient of the whole solution is going to be function of t, because this is only representing hx. It was for t equals to 0 case. T equals to 0 case. Is it clear?
Yes.
That is u xt is equals to summation n varying from 1 to infinity. We are assuming that this is u and t, and this is the eigenfunction phi n x. U and t is basically because if we are going to express this xt over hx, so this is and x double dash over x plus lambda is equals to 0. So it is going to give a series, and the solution will be coming in the form of sine, and eigenvalues will be varying over the set of integers. So that's why this n is coming, n is varying on the set of integer. Now we are assuming that this is a convergent series, so we can pass the derivative inside the summation to write this u n t and phi n x
Symphony.
summation n
It's
varying
essentially
from
the-
1 to infinity. This is ux comma t. So basically how the author is taking ux comma t, he took u n t phi and x. This is the separation of variables. So if we are going to write the equation for this, then it is going to be un double dash t over unt plus lambda is equals to 0. So we can take the derivative of this equation, this subseries, because we are assuming that it is a convergent series. It is a convergent series. So when we are going to take the second order derivative and then going to add, so it will be u t t plus this lambda of u is equals to 0. Just pass this inside this. So it is going to give us u n double dash t plus lambda n u n t, that is equals to 0 for each n, because it will be coming like summation n varying from 1 to infinity, and phi n x equals to 0. So this phi n x cannot be 0, so we have to take this term equals to 0. Basically, the property of integration. And in this expansion, we assume it minus lambda, so that when it will pass to the left hand side, it is going to give us the positive eigenvalue. So because of that, since lambda n is assumed to be greater than 0, this ordinary differential equation has general solution unt is equals to an cos of plus bn sine square root of lambda n t. Now at t equals to 0, we obtain un0 is equals to an. And if you guys remember that here we have the mixed boundary condition, so it is basically the Robin boundary condition. So the condition is on the u and its normal derivative in t direction. So what is going to be un dash is equals to going to be
Según el informe de la Federación de Rusia, del informe diario, las bajas de parte de Ucrania en la zona se incrementaron en 200, ¿vale? A comparación del día de ayer, por lo cual pues podemos ver, según los informes de la Federación de Rusia, pues una intensificación del combate que ha sido más que obvia, ¿no? Hay que comentar de que también se ha informado de que las tropas rusas bombardearon específicamente Ocheretine, que como saben pues es un poblado donde pasan líneas ferroviarias, que pues es una de las líneas principales que utiliza las tropas ucranianas para pues mover equipo pesado y desembarcar unidades nuevas, equipamiento, arsenales, mover unidades mecanizadas y mover sus tanques o sus APC y descargarlos en esta zona, y al parecer una unidad de refuerzo por parte de Ucrania cuando comenzó el combate por la zona norte de Turquía, al parecer pues bombardearon con munición de LRS. Y pues según algunos, eso es lo que nos cuentan los rusos, lo único que podemos confirmar es que en la zona, en el mapa del incendio de la NASA, pues todo el poblado en ese día de ayer, pues hubo un momento en el que pues incendió todo el poblado. Según los rusos destruyeron el equivalente a una compañía ucraniana apostada que estaba descargando su equipamiento en la zona, y pues de momento estaremos al pendiente si nos dan los rusos en un futuro alguna visualización con drones o con algo de que represente si eso pasó o no de forma ya fidedigna, ¿no? Un poco más veraz. Ahora, en la parte oeste de Krasnodarivka, primero que nada hay que comentar que la situación se encuentra un poco de esta manera, ¿no? Específicamente en esta dirección. Como saben, este mapa es un poco mal organizado, pero podemos irnos al mapa de acá que lo representa mejor. En verdad, las posiciones rusas se encontraban como que dentro del poblado y en algunas líneas de bosque exteriores. Pero como pueden ver, pues los ucranianos tenían algunas líneas defensivas que sabíamos de antemano que pues tenían construidas incluso algunas posiciones de trinchera en estas líneas de bosque, que al parecer pues todas esas líneas de bosque fueron penetradas y fueron tomadas.
To over the period, I don't remember the period in this case, the integration of 0 to
omega.
Yeah. And phi n of x by g of x.
Yeah. So since here we are not aware of the dimension, so we are writing dx. If it is n dimensional, so it is basically going to be dx1, dx2, dx3 and dot dxn. So it is a notation. So don't worry about that. If it is one dimensional, so this is single x. If it is n dimensional, so dx1, dx2, like this integration will be n because the dimension is n. So that is understood to all of you. So every time I am not explaining the same thing. Suppose it is a small n and Bn, suppose it is small Bn, then it is going to be omega hx phi of nx dx. So small bn will be. See, here I'm not writing anything from my own intuitions. Everything you guys are telling me what will be the next step, what will be the next thing is coming. So I am assuming that you know how to solve this kind of problem, isn't it?
Por las tropas rusas. Tenemos confirmación por los mismos ucranianos de que las tropas rusas han desembarcado grandes cantidades de infantería, específicamente en esta zona, con múltiples blindados que se han hecho con el control de las trincheras de la línea ferroviaria y que ahora hay combates por la parte noroeste de Verdishne y también de Stepove. Sí que es verdad que hay que comentar de que está en una zona de que nadie ha reportado cómo está Stepove, si es ruso, si es ucraniano, si está en la zona gris, no se ha reportado nada. Pongo en un asterisco porque ninguno de los dos bandos pues, ha proclamado sobre este poblado. Los combates se centran más en Verdishne, que es un poblado pues un poco más importante para los dos bandos, ¿no? Ahora, también sabemos que los rusos, algunos pues, han comentado esto de que pues, fue un movimiento erróneo de los rusos, fue un movimiento de fracaso de los rusos. Que los rusos logren penetrar por lo menos 2 líneas defensivas exteriores del poblado que estaban conteniendo a la dirección de Krasnohorivka y que logren acercar sus vehículos hasta la posición de desembarque y que en los videos se vea que de una columna de APCs solo es destruido uno con un ATGM, eso significa que la situación ucraniana o no había munición de artillería o no había suficiente munición de ATGMs o pues a lo mejor la respuesta de las tropas ucranianas se vieron sobrepasadas y tuvieron que retirarse y pues por ese motivo pues los rusos se ven en ese video que desembarcan como 100 soldados y comienzan a esparcir a través de los
you guys, for the sake of convenience,
por lo cual,
you take Bn
yo no
equals
sería
to
tan
0.
listillo de
If for
decirle
the
que no,
sake
que los
of
rusos han
convenience,
fracasado
you
porque
take
en
Bn
ese video
equals to 0,
demuestra,
then
primero que nada, que las dos primeras líneas defensivas en esta zona de parte de Ucrania, líneas defensivas, colapsaron y que los rusos pudieron incluso meter columnas de vehículos sin ser atacados por artillería ni por grandes cantidades de drones y que solo un ATGM puede disparar, al menos en lo que se ve en ese video, ¿no? Por lo cual entenderán que es una situación en la que, en mi opinión, representa el nivel de situación que estaban teniendo las tropas ucranianas y que pues la desorganización de que seguramente algunas de esas tropas ucranianas tuvieron que retirarse de forma masiva, abandonando algunas posiciones o equipamiento pesado que cubría las trincheras para evitar.
What is the frequency? At every this time step, it is going to repeat itself, isn't it? So this is the frequency. When it will be completing this cycle, again it will be coming because it is a cost function. So its period is 2 pi. So the period of this function is going to be square root of lambda n over 2 pi, isn't it? So this will be the frequency of that harmonic motion. This term because we are solving a wave equation, so that wave is going to repeat itself in some frequency. That when it is repeating, then that is the frequency, because this is a fully linear wave equation, fully linear, not quasi-linear, not non-linear. This was a fully linear, isn't it? Because from this equation, if you remember, then we wrote the advection equation. Do you guys remember the advection equation? Do you guys remember how I write the advection equation with the help of this equation?
Yeah, it was a multiplication transport equation, right?
Exactly, yeah. So this was
well the conjugate of transport equation.
Exactly. So the del over del T minus del over del T, because C equals to 1 here. So I of del U over T plus del U over del S. So this becomes the advection equation. So this is a fully linear equation. So the solution of this fully linear equation is going to be a linear wave. They're going to be a linear wave. So after a finite time, like for a fixed time, it is going to repeat itself. It means it will have a homogeneous frequency. So if for the time being, for the moment we are taking, even if you are going to take Bn equals to something, then you are able to calculate the periodicity of this linear combination. It's not it. So what will be the periodicity of this linear combination? That is going to be your frequency. But for our sake of convenience, we are taking Bn equals to 0. So then we will be left with only one function, that is a cos function, cosine function. And we know that the period of a cosine cos p of x is p over 2 pi. So after this sequence, after this time, it is going to repeat itself. So this term exhibits simple harmonic motion with frequency Fn is equals to square root of lambda n over 2 pi.
Que los rusos avanzaron contra esas zonas con vehículos blindados. Así que de momento hay que esperar a ver qué va a pasar. Es verdad que los rusos pues en este momento tienen más que nada la ventaja todavía en combates. Todavía se reporta que las tropas ucranianas pues están reforzando la zona como tal para mantener un contraataque desde la parte norte, desde la parte sur. Pero hay que mencionar de que los rusos están todavía intentando meter tanques y vehículos. Y pues los ucranianos presentaron un video de ataque a 2 tanques rusos, ¿vale? Pero algunos estaban comentando de que el video puede ser falso, puede ser de otra época, porque en ese video pues se ve que el campo tenía como que nieve, ¿no? Por así decirlo. Entonces no se sabe si es de ahora, no, o sea, no nieve, sino el césped estaba ya demostrando que ya estaban en la entrada de época de invierno, ¿no? Que pues todavía no está de esa manera este sector de momento, ¿no? Pero es bastante curioso. Lo que algunos también están especulando es que algunas fotos y algunos videos en la parte norte específicamente son de otra época o son de otros frentes. Por ejemplo, hay una foto del frente de esta zona del depósito de basura que pues algunos están especulando de que en verdad esa foto es del frente de del frente del poblado de acá de Novoapocalipka, están intentando atacar los rusos, ¿no? Y de momento pues es una incertidumbre de ver, como digo, como los rusos no han confirmado nada, pues poco más podemos comentar. Ahora, eso en cuanto a la parte norte, que tengan presente que en este momento se están intentando alcanzar con la parte norte en una cabeza de puente. Los rusos han habido informes de que supuestamente han entrado a la parte norte, pero que han sido repelidos, que han entrado, que han salido, pero bueno, que quede presente que pues toda la zona está ya llena de tropas rusas y al parecer las tropas ucranianas pues de momento no han logrado repelerlas o no tienen por lo menos las unidades de artillería suficientes o las unidades incluso de tanques como para contraatacar en este momento, ¿no? Y como digo, este pobre pues no sabemos cómo va. Ahora, en la dirección de Krasnohorivka a esta
Just take a look at the problem and just tell me why I'm calling it initial boundary value problem.
Because we have boundary condition and initial conditions.
Exactly. So t equals to 0 is going to give us the initial condition, and this condition is giving us the boundary condition. And also, since we are proceeding with the help of eigenfunction method, so we put an extra restriction on the function g and x that it is going to be 0 on the boundary of the domain, and then we solve the problem. So, question first, just the initial boundary value problem.
Una zona de basura pues que no importaba, ¿no? A ver, ese es el copium que nos están vendiendo, pero les quiero recordar que pues por lo menos los que hayan seguido el canal hace tiempo sabrán que los ucranianos tenían una tremenda fortificación en esta zona cavada alrededor de la zona para incluso lanzar ataques contra Vesele, porque este mapa no lo representa, pero por ejemplo sabemos que está 100% bajo el control de las tropas ucranianas, de las tropas rusas, y pues esta zona incluso es esencial para controlar lo que era H-20 y que los ucranianos han intentado reiteradas veces lanzar ofensivas desde esta zona incluso con tanques para tomar Vesele y cortar la carretera H-20 para poner en un cerco operativo, un cerco total Krasnohorivka, ¿no? De parte de las tropas rusas, que no lo han logrado y que incluso ha habido batallas de tanques en estas dos posiciones. Que el que diga pues que esta zona no era importante está mintiendo, porque esa zona incluso sabíamos que había sido reforzada con búnkers de concreto y pues es una zona bastante importante, pero Lo último que sabemos es que los rusos pues sí que han logrado afianzarse con toda esta zona de acá,
each other.
por lo
This
menos hasta la zona del
accounts
Versoves,
for
lo
the
cual pues
coherent
significaría el
perception of
frente
a
de
single
esta
tone
manera, ¿vale?
corresponding
Pero
to
las tropas
vibrating
rusas al mismo tiempo pues han
strings
presentado
on a
algunos,
musical
este sí, un
instruments.
video de parte de Rusia, de que al parecer pues habían
This,
tanques de Ucrania en esta línea del bosque, en la línea ferroviaria,
this
y
was
que
one
al
of
momento
the
de que los rusos tomaron esta
application of
posición
this
pues habían llevado
section.
equipamiento un poco más
So
pesado,
we
que
have
habían
the
llevado
application
HTs,
vibrating
Cornets, y
string,
pues han atacado a
and
los
we
tanques
have
ucranianos
seen
forzándolos a retirarse al
electrostatics.
otro
I
lado de
think
la
there is
línea
only one
ferroviaria.
left.
De momento no se ha reportado qué tal
We have
está
seen
la
two
situación, pues
examples,
los
isn't
ucranianos
it?
están contraatacando desde la planta química
Electrostatics
del
and
norte,
this
del
vibrating string. I
suroeste.
think vibrating string was
O
much
si
easier
de
than the
momento pues los
previous
rusos
one.
están bajo su presión ucraniana o
So this
directamente pues están
accounts for
organizando la defensa y despejando todo el lugar para luego lanzar un
the
ataque contra la parte o contra Besele o incluso
coherent
contra la zona de la zona industrial, ¿no? Lo que sí que sabemos, en la zona
perception
industrial han habido
of
ataques
a
aéreos de parte de la Fuerza Aérea, Fuerzas Aeroespaciales de
single
Rusia, y
tone
pues han habido fuertes incendios, al parecer algunos productos químicos, más que nada algunos productos
corresponding to
am,
a
basados en petróleo, pues han ardido y pues se ha visto la columna de humo de ese tipo de químicos incendiados
vibrating
a distancia incluso de
string
Donetsk, ¿no? Que al
seen
parecer pues toda la zona
on
está
a
inundado de un humo bastante espeso por el incendio que ha ocurrido
musical
dentro de la fábrica, ¿no? Ahora,
instrument.
eso en cuanto a la parte norte, como digo, hay que comentar de que supuestamente
And
los
we
ucranianos
know that
presentaron
if
un
it is a
video, bueno,
two-dimensional
perdón, una
problem with
fotografía en la que
one
pues habían
variable and
presentado
x
de que
one
los
is
rusos habían
spacial
perdido
variable,
cinco
then the
vehículos,
function phi n x is going to
cinco o cuatro
be
vehículos en una
simply
carretera que habían
sine
sido abandonados por las
n
tropas
pi
rusas.
x by
Y
l,
pues algunos estaban comentando
and
que ese
this
video
will
es falso,
have
que esa foto es falsa, que es antigua, que es de otro frente. De momento no lo
exactly
sabemos, como digo, los rusos pues no han confirmado nada y no han
n
desmentido
minus
tampoco nada, por lo
1
cual tomaremos en cuenta que pues
zeros.
serían
So how
unos
many
7
nodes
vehículos
we
rusos
have?
los que se han confirmado que han sido destruidos en esta maniobra. La infantería rusa de momento pues no se ha visto que han
How many nodal points the problem will have? If this function is going to have n minus 1, 0, then how many nodal points this problem will have? Yvonne?
Yes?
How many nodal points this problem will have? So what we write
N?
nodal point
N?
n minus 1 because we are in the
Yeah.
this function has the function where the points where this phi n vanishes, that points are known as nodal points. So it will have n minus 1, 0 because as soon as l will be n, so that will be cancelled and that will be 0. So it will have exactly n minus 0, n minus 1, 0. So the solution will have n minus 1 nodal points. And at these nodal points, the solution of the system are going to remain constantly 0. And when this omega, here omega I took 0 comma l. If this omega is not a 0 comma l, rather than it is 0 comma a cross 0 comma b. Suppose this is a two-dimensional reason. Then the frequencies will no longer occur as integral multiples of each other, and the nodal states will be curves. So this will be a problem in your assignment. You are going to solve it when it is two-dimensional. So in particular, again, it will have an observation that a vibrating drum head does not create a single musical tone unless the vibration corresponds to one of the spatial solution, for which the vibration leaves certain points on the drum head stationary. So this is the problem. I will keep in your assignment. Next, we are going to proceed with the energy methods. I haven't written this problem in your notes, so this will work as the notes for you. I was assuming that you guys are gonna solve this problem. So till this point, we can see that most of the analysis of harmonic functions, so basically most of the analysis of the solution of the Laplace equation has depended on Fermi representation formula that include the fundamental solution like Heaviside function, delta function, green function, and the Poisson kernel. This was the most important thing. We calculated the closed form solution of the Laplace equation, isn't it? We calculated the closed form solution of the Laplace equation, and then we came across the point that solution is of this form 1/2 pi integration a to b, and then this function and the boundary function. This is going to be the Poisson kernel. So basically, across the boundary, this is the weighted function. So till the date, we have the idea of the green function, the fundamental solution. Each solution has represented in the terms of the fundamental solutions, that is the delta or Heaviside function solution, green function solution, and Poisson kernel solution. Now we are going to proceed with the energy method. So we will not elaborate it in a very large way. We will go through the short techniques and then we'll come to the point. Still, I have to discuss the subharmonic function and Perron's method. Yeah. So today I uploaded the notes that is containing the subharmonic function, and still I'm left with the Perron's method. I think Monday will be the last class for this section. It was a very long section, although. Here we demonstrate some energy methods, procedure, techniques involving the L2 norms of various expression. So first we will talk about the uniqueness of the Poisson equation. And before coming to the point, I would like to ask you, Roberto, are you here? Can you hear me? Okay, so the last topic was clear to you, eigenvalues and eigenfunction. No, okay. Yvonne, was it clear to you? Yvonne, are you here in the class? No. Rebecca? Camilo?
Yeah, I think so. I just need to read again the topic, I think.
Class approach was clear for how we are proceeding.
Yeah.
Yeah, for me too, like I have to read again everything.
Although class approach is clear or not, how we are.
Yes.
Okay,
Yes.
then fine. Because In the last, we have solved a number of problems. Now we are going to be little bit relaxed because we have some theorems and proofs. Consider first the boundary value problem in U and U equals to Z on the if I am going to write it in Spanish, so it comes sobre. Isn't it? Yeah, then fine, I know. I just remember. Now, assume U is open, bounded, and the boundary is continuous. So, first comes the theorem of uniqueness. For f equals to 0 and g equals to 0, there exists at most one solution u belongs to C2 u bar of 1. So if it is a Laplace problem with zero boundary condition, then there will be at most one solution, because for the Poisson equation, if you guys remember, then we were talking that it may have more than one solution, but when it is a Laplace equation with the zero boundary condition, then it will have at most one solution. So, proof. Assume it has two solutions. U is the given solution and U tilde is another solution. Then set W equals to U minus U tilde. If I am saying that U is a solution and U tilde is a solution, then for the Laplacian problem, del U will be 0 and del U tilde will be 0. And we know that Laplacian is a linear operator. Laplacian is a linear operator. So when we apply del W, it is going to be del U minus del U tilde. That is going to be a 0. Did I prove that Laplacian operator form a group, not a group? It satisfies the property of, what do you call this property? If U1 comma U2 belongs to a set, then alpha U1 plus alpha U2 belongs to that set. What do you call this property? Alpha 1 and alpha 2. I proved that the Laplacian operator satisfies this property. So using that property, it comes in U. And so an integration by part shows 0 is equals to minus integration U W Laplacian. What I did, just see. We have Laplacian of W equals to 0. I multiply W, so it is 0. It is going to be 0 if I so equals to 0. Now the next condition which we have given, that U equals to 0 on the boundary. So the solution u tilde will also be 0 on the boundary. So the solution W, that is u minus u tilde, it is also going to be 0 on the boundary, isn't it? Now, if you guys remember, so what is this del W? This is basically this operator, and if we use the if we use the integration by parts formula and use that, the value of W is going to vanish on the boundary. Firstly, we will use the method of integration by parts, and then we apply the Green's divergence theorem. Like in the domain, it is going to be the integration on the boundary, and when I am going to take the integration on the boundary, then because of this condition, that is going to be 0. I am just explaining in the air because you already know that. So this can be written as, and since I am just passing one operator, so because of that minus 1 will be coming, isn't it? So for me, I assume that you know everything. That's why I am just writing, because you guys have done a lot of calculations. So it is obvious for me to assume that you know this formula and I am writing this. So this is equals to 0. Now, if the integration of a positive quantity is 0, then what does it imply?
The function must be 0.
Exactly. The function must be 0 in u. And since w equals to 0 on delta of u, we find by, okay, I am not going to write it. You are going to respond me. This gradient is going to be 0. It means w equals to
Constant?
constant, and w is a harmonic function and it has a 0 value on the boundary. Then what maximum principle says?
Omega must be 0 on all domains.
Exactly. So the maximum value is 0 and it is a constant value, and minimum value is also going to be 0 because W is a constant. So using the maximum minimum principle, we can say that W will be 0 inside the domain. I was saying now you know everything. I don't need to explain anything. So we find by maximum minimum principle of harmonic function that W is equals to 0 in U. It means U minus U tilde equals to 0 in U. It means U equals to U tilde in U. It means this Laplacian is going to have a unique solution when it has a zero boundary condition. So this Laplacian is going to have a unique solution when it has a zero boundary condition, isn't it? Is it clear? Uh, I was just curious to know if I was explaining this thing in the Spanish, so it was very easy for all of you. It was going to be easier for all of you, Ivan, Camilo.
Can you repeat the question, please? I don't understand. So,
Sorry,
can you repeat the question, please?
I was saying that,
Are you talking about the assignment?
no, I was saying that suppose I was a Spanish person and I was teaching you in Spanish. So the topic was going to be easier if I was teaching in Spanish.
Maybe can be easier.
Maybe more easier. I think that it is easier for the time being, but was it going to be more easy? Dirichlet principle. Next, let us demonstrate that now this Dirichlet principle is going to talk about the solution of the Poisson equation. Here we were talking about the uniqueness of the solution of a Laplace equation where the boundary condition was zero. Now the Dirichlet principle, it talks about the solution of the Poisson equation where it will have a Dirichlet boundary condition. Okay. Next, let us demonstrate that a solution of the boundary value problem first for Poisson's equation can be characterized as the minimizer of an. Have you guys studied the calculus of variation in your undergrad studies? Appropriate functional for this. Do you guys have idea about the calculus of variation? For this, we define the.
In my case, no.
But you studied the last semester with Professor Monica.
Oh, yeah. Yeah.
For you, I know, so you cannot say that you don't know.
Yeah.
Ivan, are you sleeping? Ivan, are you not present in the class?
Just it. No, I'm not sleeping. No, just in some examples of analytic mechanics, I used variational principles to obtain the maximums and minimums of the Lagrangian.
So can you tell me for this Poisson equation, for the given Poisson equation, what will be the energy functional?
I have seen that. I don't remember what's the functional. It's related to the Green's functions.
Yeah, it is related to the Green's function. So again, we are going to write it like, just remember that del U equals to F. If W is a solution of this, then the del W is going to satisfy F, isn't it? Now, what you will be doing? You will multiply W here, you will multiply W here, you will include over and du, and then you are going to pass one derivative on W, then it is going to be minus gradient of W square
Okay.
No, so I get minus if you remember. So my plus is equals to integration WF integration WF minus WF and then over the boundary. So this is going to define the energy functional. This is just an approach. Like you already know, so I don't need to explain these things because you guys already know what is the energy functional for a Poisson equation, or you can say that what will be an energy functional for the Laplacian equation with a source term. So this thing you know, just let me write the definition. But here the boundary was not zero, so admissible set comes. So you have, if you want to know a lot about this energy functional, then I can recommend you, like this is all available in your book. Just let me tell you the page number. So it is not here, not exactly what I wanted to tell you. There is a part calculus of variation in the Lawrence Evans book, but it does not have the concept which I am going to let me tell you from the another book. So in case if you want to study the theory of the energy functional, because I cannot derive here, it will take a longer time. It has a definition that is coming from the calculus of variation. Yeah, so in the McOwen book, you can go over the page number 391. In the McOwen book, you can go over the page number 391. And in the Lawrence Evans book, you can go over the part 3 and chapter 8, the calculus of variation. And in the calculus of variation, when you will be going on the weak solution of Euler-Lagrange's equation, and before that you have first variation, second variation, and then system. I think that is going to contain that part. This is the main part that is coming from the variational method. Okay. Minus WF D of x and W belonging to the admissible set Now write the theorem. This theorem is known as Dirichlet principle. So this is, if you will take a look at your syllabus, then this is the topic which I am covering today. This is the topic, energy methods and Dirichlet principle. Energy methods and Dirichlet principle. Now assume U belongs to C2, U closure solves equation number first. Solves equation first, then I of U, the energy functional of this is going to be the minimum of the energy functional which is defined on this admissible set, and W is coming from the admissible set. Conversely, if U belongs to A, satisfies equation number second, then U solves the boundary value problem first. In other words, if U is belonging to the admissible set, the PDE minus del U equals to F is equivalent to the statement that U minimizes the energy I Yes, we are going to prove this theorem. Now choose W is coming from the admissible set, then equation first implies, this equation implies zero is equals to okay. What is this U? U is the solution of equation number first, isn't it? Here we are assuming that U belongs to C2 U bar, it solves equation number first. So U minus and W is coming from the admissible set. So basically our aim is to prove that this I of U is going to the minimum of this energy functional where W is coming from the admissible set. So dx. Just open this operator. Zero equals to integration omega minus take outside U minus W and minus of U minus W d of x. Okay, tell me if U is the solution of this equation, then what will be the value of U on the boundary? G. And if W is coming from this admissible set, so what will be the value of W? Z on the boundary. So what will be value of U minus W on the boundary?
0.
0. So I'm just going to the next phase. You are going to tell me everything you already know. You guys are very smart. So what will be the integration of this term? What will be the integration of this term? This term. This is Laplacian. What will be the integration of this term? Just you solved in the previous pages, isn't it? Here I was doing the integration. So it is going to be the, see, this is gradient square, is not it? Some people write gradient square, some people write d. It is just a way how you are going to write it, because in my notes I was following some books, so I write d. But here I am writing gradient, so don't get confused with that, because in my notes I am writing the notation of Ivan's book. So in the notation of Ivan's book, if you notice that this symbol is represented with d as well, isn't it? So because I was just seeing my notes and then I was seeing that I have written D. So this, and I will pass one Jacobian, so this will be Jacobian of U, sorry, gradient of U and the gradient of U minus W, isn't it? And minus minus will be plus. Why you guys get confused when I am asking this? Is it not clear? Is it not clear? Okay.
It is clear.
So why you are not speaking? Just respond to me, na?
I'm thinking more before I speak.
What?
I'm thinking a lot more before I speak
Oh.
because most of the time I just uh, express my thoughts and not like solid ideas.
So you can open it like gradient of u, and this will be gradient of u minus gradient of w, because gradient is again a linear operator, so it will pass. And then you can write it like gradient of u dot gradient of u minus integration dx, gradient of u dx minus integration f of u dx minus integration f of w dx, and that is equals to 0. Now take u one side and w one side. So it will be u gradient of u square minus, since f is a linear function, u might be a vector function, but f is a linear function, so it can be any side. U f dx is equals to u gradient of u gradient of w minus wf dx. Now I am going to use the Cauchy-Schwarz inequality. So I can write it is going to be less than or equals to integration u gradient of u dot gradient of w minus w of u dx. So using the Cauchy-Schwarz inequality, this can be written as integration u half
Habría una gran agradecimiento, ¿no? Pero sí, bueno, de regreso a participar,
dw
se los agradezco. Van a llegar
minus
y
integration wf.
también tendremos la puerta de preguntas, charla, ¿no?
So the inequality is basically.
Sí, les vamos a si no publicar no lo recomendaría pues sí para la él funciona formulando que todos tenemos que aquí hay mucha información referente a la parte de apoyos, de tutorías, becas, coordinación, todo lo de trámites, todos los apoyos y demás, ahí viene información.
Gradient of w square. So this is the inequality, Cauchy-Schwarz inequality. And then we use the Cauchy inequality. Cauchy inequality is used on this one. And then Cauchy-Schwarz inequality is this one. This is functional analysis, so you don't need to go in a very detail. Cauchy inequality. For your understanding, you may write it Cauchy-Schwarz inequality. So using this inequality, we will be getting this equation. Now rearranging it. Rearranging gives. How you will rearrange? What I will be doing, I will subtract minus half of gradient of u square from both sides, minus half of gradient of square from both sides. So this will be integration u half of gradient u square minus u f dx, and since it is subtracted from here, we will be left with only this term. Okay, so is it clear? Now what is this? This is energy functional for U, and this is energy functional for W, and from where W is coming? From the admissible set, from the admissible set. So since U is also coming from the admissible set, because U is a solution of the given differential equation, given partial differential equation, and it is satisfying the condition equals to 0. And since U is coming from this, so say that W is the solution of the given Poisson equation. I didn't say that W is the solution of the given Poisson. I just defined this energy function. What is the one property which is making it the admissible set of energy function for the Poisson equation? The only property is that the admissible set which we are defining, this W is going to take the value that this W is going to take the function G on the boundary. Only similarity is this one, and because of that we are able to write this inequality. Is it clear? Because if it was going to be a solution, then at this step we were going to take we were going to obtain 0. So here from here we are able to prove if it is already a solution, so it will be giving us 0. It will not give us an inequality. Now second, now conversely, suppose equation, this is the equation second, conversely suppose equation second holds, then fix any V belongs to C, C infinity U, and write iota of tau defined in such a way I energy function of U plus tau V. Tau is a real number. Since and also assume that V equals to Z on the boundary of omega. Then V is the infinite time continuous, then for sure it is going to be second order derivative is going to be continuous. So V will also belongs to the C2 domain, and U is also belonging to C2 domain, and V and U is satisfying this boundary condition. So can we say that U and V are belonging to the admissible set? What was the admissible set? Admissible set that W is belonging to C2 omega and with the boundary value equals to 0. So if U is belonging to C2 omega, U is belonging to C2 U bar and V is belonging to C2 U bar, because they are satisfying this boundary condition as well. So they will be belonging to the admissible set, isn't it? Since U is belonging to C2U, V is belonging to C2U, and additionally it's satisfying the property V equals to Z on delta omega, and U is a solution, so U is also equals to Z on delta omega, so they are belonging to the admissible set. And if U and V are coming from this admissible set, so any linear combination 1 dot and tau is a real number, tau V will also be belonging to this admissible set, because U is C2, V is C2, so their linear combination is going to be C2. U equals to Z and V equals to Z on delta omega, so their linear combination is also going to be Z on the linear combination of this G on delta omega. So this will be coming from the admissible set. Since U plus tau of V is belonging to A for each tau, the scalar function, I dot has a minimum at 0, and thus I dash 0 equals to 0, where dash equals is the derivative with respect to tau, provided the derivative exists. But I of tau is equals to integration U half modulus of U plus tau dV square minus U plus tau V F dx according to the definition of the energy function, and this is going to be half du square plus tau du dot dv plus tau square over, just open this square. So modulus of square is simply going to be this square, and we can put modulus here. dv square minus u plus tau v f dx, and consequently 0 is equals to I test of 0 is equals to u du dot dv minus v f dx. So this is I tau and when I will be keeping tau equals to 0 here, tau equals to 0. So just wait. So this was I of tau. If I am going to take the derivative with respect to tau, basically I am writing it as d over d tau iota of tau. So d over d tau over this. Now u is independent of tau because tau is a scalar coming from, tau is a variable that is coming from R, not from R1. So the derivative of this with respect to tau will be 0, and we are assuming that the boundary is going to be constant. So using the Laplacian rule, even it is going, when we pass this derivative inside the integral, the boundary, then the derivative of the boundary value like a to b is going to be 0. So this term will be 0, and the derivative of this term with respect to tau will be du dot dv. The derivative of this term with respect to tau will be 2 tau over 2 mod of dv square, and the derivative of this term with respect to tau will be, this will be 0 because u is independent of tau and minus v f. Now when you will be calculating I dash of 0, so this term will vanish because tau is appearing here. So this is, we will be left with this. Is it clear? And this is equals to integration of u. This can be written as minus of Laplacian of u v minus f of v d of x. This one derivative is passed to this one. So this is equals to u dx, that is equals to 0. This identity is valid. Valid
habido
for
bastantes pérdidas, más que nada la mayor pérdida de infantería espontánea que he visto de parte de Rusia en la zona
that is
es
coming from
supuestamente si
CC
confirmamos
infinity v
estos
and
dos tanques que se dirigen de
so
Krasnohorivka
minus of
a la zona
Laplacian
sur
of u
a la
equals
zona
to
norte
f
de
in
Brest,
u.
pues podríamos confirmar de que sí,
So
porque había
here we
infantería
prove
subida
the
encima de estos
Dirichlet
tanques y pues se ve que
principle.
son impactados por ATGMs, ¿no? Por lo
Now
cual pues
you
esas
may
serían
write
las
a
peores
note.
pérdidas de infantería y pues veremos qué pasa en la zona porque todavía hay unidades de Storm Sea y
Dirichlet
unidades de
principle is an instance of the calculus of variations applied to Laplace operator, or you can say Laplace equation. We are using the energy functional that is coming from the calculus of variation. We are not deriving that energy functional. So that was the point where we are using this calculus of variation, and then we are using some functional analysis, because all the calculus of variation use a lot of functional analysis. So I am stopping this class here, and see you in the next Monday class. If you have any doubt, then
Thank you so much.
okay. Bye.